I'll spend like 3 hours on it.
3 hours doing what?
Like one pissed me off so much. Then by the time I was done, I remember, oh no, I got camp homework to do. I do another 1 hour. Then I also got English, but now I give up in the school.
How come you got so much homework?
It stacks up, man. Then by then now I got like 7 homework. I also don't know what I do. Next Monday is my Chinese oral. I haven't started revising.
Oral is in for like prelim. Yeah, okay. Looks like you're in bad shape, huh? Let's try to catch up. I mean, okay, don't talk about now, but try to catch up during the June holidays. Everything, everything. Yeah, new chapter, speed of reaction. Speed of reaction. Yeah.
Moral physics. What?
Still on electromagnetism. Okay, come. Very simple. Speed of reaction. Okay. Now, I can tell you the most common type of reaction they'll give you. Something like this.
Or is it new one?
This is a new one. New chapter. Acid plus matter. Stock plus 金钱. Yeah. Then the second kind, these are the two most common reactions under this chapter. There are others, but I'll tell you the most common one first. So I think no need to elaborate further. You should be familiar with these two reactions. You should. The other one is acid plus carbonate. What do you get, meeting? Metal carbonate? Do you get metal carbonate? No. What are the products? Plus. Now, the obvious point is these two reactions, they give you what are the observations? Yes, of course. You should use the technical term. Okay, so how to measure the rate of these two reactions? There are two ways. As I said, there are other ways, but I'll tell you the two most common ways first. One is by the way, before I forget, the setup is in a flask, of course. The reaction occurs in a flask. What is the one? Conical flask. So the first method, reaction is in the flask. The first method is to place the flask on the weighing scale, weighing balance. Okay, it's method one. Okay, method 2. Reactions are still in a flask. Except in this case, you also add in a rubber stopper and a delivery tube. And you end up in a, hopefully you haven't forgotten this thing. What does this look like to you? What? Upward, no, not exactly. I mean, maybe I didn't draw exactly that well, but it's not that bad either. What is this? Okay, gas screenshot. Now, two possible setup. Either one or the other. Now, since I'm talking about speed, you will be measuring something with time.
Distance.
What distance or what? This is not kinematics. There's no distance here, so huh? No, actually, I already give you the answers, right? Valence. So what does a valence measure? Yes, mass versus time. Of course, to be more exact, it's the mass of the contents in the flask. Right, time depends on how fast this reaction is, typically seconds or minutes. Okay, the second one, take note. The second one obviously is not measuring mass. What is it measuring? Yes, volume. Yep, volume of gas. Versus time as well. How will you what will you expect to observe for these two graphs? Which one is down? Okay, for this one, you should see a downward curve. Don't go and draw upward curve. You should see this. Yes, good. From 0, it should increase from 0. Okay. So, in fact, next time you don't even need to tell you. Once you see a downward curve, it's mass versus time. Upward curve, volume versus time. Okay. Yes, Xinjie. A few things. Do you expect your curve to go to 0?
No.
No way. Don't draw to 0. I mean, write it down somewhere. Your teacher is going to penalize you 100%. Doesn't go to 0. There will always be some content left. Second thing, by right, you should continue drawing your curve until it stabilizes. It doesn't decrease any further. By right, you should see that horizontal part. Yeah. All right, so this point is important. That first point when it stabilizes. Now, to be more exact, this is the point at which gradient becomes 0. Why is this point important? Why is this time important? Your curve has a gradient of 0 starting at this point. Yes, right down, reaction stops. Why does reaction stop? Okay, right now also, because to be more exact, limiting reactant is used up. You have not forgotten limiting reactant. Yeah, everything is linked together. So depending on your question, it can be either the acid or the other reactant. Okay, so I think you should know what I want to tell you for this curve as well. Same thing applies. Make sure you draw until the gradient is 0. Okay, identify that point when gradient first becomes 0. Again, just jot down, reaction stops. And of course, the reason is the same. The other thing is this. For volume of gas, it starts from 0. So by right, your curve should start from 0. Initially, there's no product. Okay, let's continue. Now, for both of these curves, there's an important thing. I haven't thought about speed of reaction, right? So what is the speed of reaction? The speed of reaction is measured by, okay, take note. Yes, you're not wrong, but there's a numerical value for that. Speed of reaction is the gradient. Oh, okay, great. Or either graph. Technically, the rate. Yeah, it is the rate. But you have to recognize from the graph because the graph usually come 100% coming up. Okay, so let's say, and in your exam, I can bet you they are going to show you more than one line. So let's say I have a second line here. Tell me, red or purple, which one is faster? Red or purple, which one is faster? Which reaction is faster? You mentioned purple, why? Yes, remember it goes down faster. So make sure you don't screw on this 100% coming up. Faster, very simple, because steeper gradient. That's all. That's the easiest way to see. Okay, Ming, make sure you don't misinterpret this one. Now, same thing, I got this. Now, Ming, which one is faster, red or green? Which one is faster, red or green? Jingjie. Which one has a steeper gradient? Which one has a steeper gradient? Do you know the meaning? What is gradient? Yeah, what is gradient?
1 minus 1.
Tom, don't forget, this is right from your kinematics. The steepness increases, it means the gradient increases. Then, of course, it means speed increases. All right, does this look steeper like this?
No.
So, red is steeper. Imagine you're trying to climb up the red slope, you're going to have a hard time. This is gentle. Can Minting agree or not?
So you change your view like
Like kinematics, huh?
you never tell me that last time.
I did. I always use the word steep and gentle.
No, I mean imagine your client.
Oh.
You could have told me that last time. You went to me.
Oh, okay. So obviously steep means faster, of course, gentle means slower. That is the easiest way to see. Can don't screw on your maths. And by the way, they may ask you to calculate the gradient.
Not the tension.
Yeah, got attention. Okay, you're expected to know that. Can don't forget how to calculate gradient using a tangent. You want to ask me what's tangent or not? No need. No need,
Tension.
Okay, simple as that. Now, but we are not done. Go back here again. I'll delete some of the stuff first. Come, look at your curve. Is the speed of reaction changing with time? Is the speed of reaction changing with time? With time? Yes, okay. When is the reaction the fastest? Where is the steepest time? Don't say that. Oh, because you missed my kinematic chapter.
Huh? Oh, you mean at start?
Yeah. Hey, come, write this down.
Yeah.
This part, right at the beginning, is the steepest, right at the beginning, the initial gradient. What does that mean? That means the initial speed is the fastest. And it's the same for all reactions.
Yeah, that's good Saturday also.
No good Saturday, only good Friday. Saturday.
Oh.
Why is initial speed the fastest?
It's your turn.
Yes. Write down occasionally the fastest because greatest amount of reactants are present. These also apply the same principle to the other graph. It's the same. Can I think initial speed is the fastest. Okay, can.
Yeah, I saw. Who was the girl that sit beside me?
Wait.
Your tuition. Who was it?
For what subject?
Is it content? I mean, Cam.
Can.
I forgot.
Chloe.
Oh.
Oh, friend. They said that. Oh, yeah.
Girls sitting there.
God.
I thought it's the boy sitting there.
No, you used to. Her name was A1 something.
A?
Ashaya? No?
But I don't think so.
I saw her at the math tuition when I was walking. Yeah.
Oh,
Yeah, that one. The A grader.
she ran away.
But that was math.
Oh, no need tuition.
The need tuition, or maybe okay.
Told us that same one is.
Yeah, maybe. I shouldn't have said that.
Hey,
Oh, you need tuition.
What you always need tuition.
Yeah, I'm sure.
Only I would left home.
Yeah, you have been here for a long time.
Just one tuition.
Only your cousin is going to beat you.
Huh?
Only your cousin is going to be longer than you, I suspect.
Will man? Oh yeah, because
Okay, let's continue. Come. What if I show you something like this? Let me see. Okay. Let's say I show you something like this. Hey, confirm coming up. They're going to give you a graph with many curves, 3, 4 curves inside. So mass versus time. So mass decreases. Then I have another one. How to interpret? Why is the green curve like that? Or why, of course, you can also ask why is the red curve like that now? Notice they all reach zero gradient. Now, look for the point at which zero gradient occurs, first occurs, is about the same. So for both cases, reaction stops. Okay, they stop at the same time. But I still have to ask you, which is the faster reaction? The red one is still faster. Can agree on? Okay, faster. But how come my red one stops here? I mean, the curve is still above the red curve. Why? Impurities?
the stop code method.
There's yes, that's possible. That is possible, but actually possible but not likely. You know what will happen in that case or not? If the sub good point, the sub code that rectangle is going to be very short. You won't even see the curve. It will just stop immediately, almost immediately already.
Okay.
You won't even see this nice curve coming down. There's a more important reason that your pattern know. Okay. Because this one has less. Yes.
哎呦，
这样子。
Why is the signature off?
Confirm coming up. Make sure you have the word limiting in your answer.
I'm testing your brain. I don't think I can fix it.
Never mind, it's okay. Since I'm going to business.
Well, the one you told me about last year. Yeah, just any on your vision.
Oh, digital media.
Yeah.
Can keep that in mind. Keep that in mind. This will actually come up. But let's have another thing. Let's ask a simple question. I drew mass versus time. Can I ask you one simple question? Why is mass decreasing anyway? Shouldn't mass be conserved?
What you say?
Go on. So shouldn't the effervescence be conserving the mass too? Right? Conservation of mass? How come the mass is decreasing? Shouldn't the mass be the same?
Separation, okay.
Keep the best.
Right down. This comes up sometimes. Actually, you're right, it's the effervescence. All right. The gas product escapes from the flask.
That's exactly.
What are the escape?
Uh-huh.
That meant
Yeah. So it's not captured by the weighing balance anymore.
When it already formed, then it's already escaped. You think already what?
Yeah, but you can't just write effervescence. You think your teacher will sympathize?
Oh, so obviously the speed has a decrease, ma.
You better write something like this in your answer.
It's not always get it wrong. Yeah, I think I'm scared sometimes.
Okay, come, Jinjie.
What?
Having said that, why is for this graph, why is the volume of gas increasing with time?
Yes, sir.
Oh yeah, more and more gas product is formed. So you better write something like that. Don't just write effervescence. Okay, great. So you have the idea already. Now.
Nothing.
Okay, simple, huh? Let's go on. Now, what are the factors affecting speed of reaction?
No.
Everything is already reacted now.
Okay, before that, I forgot something. How does a reaction work? What happens during a reaction? I introduced something new. A reaction is explained by something called collision theory.
Oh, so
Thinking about atoms now. I don't know.
It's about atoms.
what make you element? One time.
Hey, this is just one of the possible explanations for a reaction. Remember bond breaking and bond forming? That's the other theory that you need to know, but this is a different theory. Now, imagine I have acid molecule, right? Then I have a metal particle. They're apart from each other. No reaction. Okay, they may be in the same system, but they are apart. So what do you need them to do? You need them to collide.
Energy, yeah.
Yes, that too. You need them to collide. And not just collide, something like that. Collide with enough energy.
Would they ask measure energy?
Not this kind. They'll ask you to measure temperature change. Can collide with enough energy. Let's say if they collide without enough energy, what will happen? Nothing wrong, they'll just bounce away. Nothing. Okay, done. Revision time. What is enough energy called? What's the energy called? Yes, excellent. Yeah, I know you have learned. I've mentioned it last week. That enough energy is called activation energy. And I think I can remember. Just to let you refresh your memory, short form is EA. Capital E, small a.
Oh shit. Video.
Yeah, it is.
Oh,
Okay. Just to add more things to you for you to remember. They find that writing collide with enough energy quite cumbersome, so they shorten this to, they call this an effective collision.
Yeah, so smart.
Yeah,
It's just long.
just as well. Okay.
I mean long.
Oh, okay. What? You have less number of letters.
I rather write something simple than to memorize something. Yes.
So it's called an effective collision. No, collide with enough energy.
Oh, this kind.
Okay, so for a reaction to occur, the reactant particles must have an effective collision. Okay, easy, You will remember. Try. But of course, that's not the end. It's never so simple.
So,
Okay, there are 4 factors that affect speed of reaction. You need to remember all four, of course. Only four. Yes, excellent.
pH got.
Hmm?
pH got.
Not for chemistry. All factors affecting speed. But pH is important.
Right, you see.
For bio,
But enter in nature, how do you continue the reaction? They don't continue.
they don't.
So you should add it in. And then take out another one.
You want to include? Okay, okay, you're right.
I said take out the
But since Tingji already said it, but okay lah. Temperature. Temperature is good. No, temperature. Heat and temperature are different. You should know better than that since you study physics.
Oh.
Okay, first thing first. Temperature affects all reactions. All kinds of reactions. Oh yeah. Of course, that include biological reactions. So in general, as temperature increases, speed of reaction increases. For all reactions. Too easy, right? But then that's not the end. You ask you to explain why.
Masters move
Yeah.
my.
So more kinetic energy. Then after you
Nothing.
yeah.
Me, right?
But this is chemistry.
Yeah, but they want to see this all. So basically temperature increases. Okay, let's be very specific. Reactant particles.
They collect more frequent.
Good. You see, she knows everything.
Then
I don't.
the bio students are screwed.
Screw? Why screw?
Screwed. They don't know kinetic.
Oh,
Oh, I took all three.
yeah, so she's the best.
No.
Reactant particles
Doesn't it?
move faster. Of course, you should know that. And possess more energy, but no need to write kinetic inside unless you want to make things difficult for yourself.
Have more energy.
Can. So, the next phrase is super important. Highlight the next phrase. So, the frequency. You don't like frequency, then you use probability. Or your favorite phrase, effective collision.
Of collision.
Hmm?
It's a rate of collision.
No, you need to write effective collision. Great, you can try. I tried a lot. Nobody has mentioned that before. You try. For what? You try a lot also. Increases. Let me highlight for you as well. This one. Super important phrase. Super important. If it is
EMI school.
EMI.
Yeah.
What's EMI?
EMI.
What's that?
Physics.
Yeah.
Oh,
Right.
oh, right hand.
Yeah.
Tomorrow. Okay.
On
Can
Friday he teach stuff. I try to stay away. I cannot sports. So I learned nothing like that.
You didn't take video of him.
He allowed take photo but then
Okay, no.
in his class he don't mind. He very nice.
Maintaining was another factor. I write it down. Your old friend concentration.
I hate this.
But this is like what? It's like the amount of limiting reaction.
No,
Yeah, the same thing.
it's not.
I
That's why it's so difficult.
think everything is the same thing.
But concentration is tricky. It only affects certain types of reactions. What kind of reactions?
See,
It only affects aqueous
Oh,
reactions or aqueous reactants.
almost everything.
For that two examples, yes.
Ah,
But for you guys, they may give you some funny examples that don't involve aqueous gases. Remember your friend Haber process?
boy.
Hey, you haven't gone through Haber process yet? No. Got it. Okay,
right.
yeah. Any aqueous or not? Nothing is aqueous.
What? What's the equation?
What's the equation?
God.
Yeah, just
Two H was I don't know. Then you get an H3.
yeah, you get this.
Yeah, 12 I think you remember the elements.
Sounds familiar.
I remember the elements. I never find it.
Oh, but all of them are gases, by the way. No aqueous. Okay, I'll remove it. All right, let's continue with this. So how does concentration affect speed of reaction? Very simple. Yeah. Concentration increases, speed of reaction increases. Oh, sorry. Let me be a bit more specific. Must be reactant, concentration reactant. Must be reactant. We do not care about products. But to ask you, explain.
No.
Higher gradient. Higher gradient difference. Higher difference of gradient. I don't know.
You remember your favorite phrase? It involves collision theory. So as the concentration of reactant increases, there are more particles in a given volume. Yes, more reactant particles.
Let's say increase the frequency of effective temperature.
Yes. You have to say that too.
Why? Everything why?
So let's have your previous. There. Okay, done. Can still coping anything?
Just came it from the
Okay. What's the third factor? It's only 4 factors. More? No, we don't care that much about moles.
Then don't give more questions. Oh my gosh.
They usually come on
Oh, that's why.
pressure.
Gosh, we're going to do this.
Everything else. Pressure. Being your old friend. Now, of course, it only affects certain reactions, not all. You should know your answer by now. Pressure only affects gaseous reactants.
Oh, I thought you knew the question.
Reactants. I'm not interested in products again. Okay, same thing. Make sure you write something like this. Pressure increases, speed of reaction increases. Okay, basically, as pressure increases, more gaseous reactant particles in a given volume. Right? They are all squeezed together. Since you study physics, you shouldn't have a problem understanding that.
Why?
That means all the particles are squeezed together. Or at least they're closer together. So what happens next? Exactly the same thing.
You just copy paste.
Oh yeah, of course.
Can you help me write?
You try to copy and paste.
Can I have a question?
Yeah.
Did anyone take triple science and then they go crazy?
No, they went on to become doctors.
I know a few people in other class they drop physics.
Oh really?
Oh, yeah. They didn't drop physics, they dropped chemistry. No, they dropped chemistry. Or they dropped physics.
Yeah, how to drop chemistry?
I want to drop chemistry.
You can't.
Won't give a shit. So I was like, hey guys, did you know acid plus metal equals to salt and hydrogen? You know what? Unless you like jerk me.
Yeah, unless they work in the chemical industry, then it matters. But since I'm going to business, then it doesn't matter.
I don't know how to read graph. The stock market.
Okay, then you better come back to chemistry.
No.
Oh, if not, go to biomed.
How many dies? I don't know a single thing about bio.
You don't know what segment can down.
What? Planet Zion. That's the only thing I know. Stomata.
I remember it yet.
Okay, last factor,
Sticker.
particle size.
Greater size than.
You should know this better than all.
So.
What kind of reactions does it affect? Affects what kind of reactions? Or what kind of reactants?
Solid.
Yes, good. Solid reactants only.
Or salt.
Solid reactants. That means if you have a insoluble reactant, then particle size will affect it. Now, this one, pay attention because this one is a bit counterintuitive. Now, particle size increases. What does that mean to the surface area?
It decrease.
Increases.
Where?
Imagine you have a big lump of reactant, one big piece of chalk compared to chalk powder. Which one will react faster? Powder, because the powder is smaller size. So overall, all the small powder particles have a greater surface exposed surface area. So remember, don't screw on this. Lots of students have screwed on this before. Your whatever surface area, not particle size, but surface area. You should have learned it right at the beginning when how big the thing is. Then you need to calculate the volume, calculate the surface area. Yeah, so okay. Oh, by the way, sorry, I think it's easier for me if I reverse it. Reverse the other way. Particle size decreases, surface area increases.
It's good for them. It's just that big.
Yeah, so clever. So I copy and paste this.
If you can just cancel the arrow up, just drop arrow down.
Okay. Okay, done. Okay lah. After today, you remember that phrase already. Frequency or effective collisions increasing. Oh sure.
Probability sucks. It really sucks. Actually, probability. It's the worst subject, worst topic ever.
Oh, okay. That'll be worse.
Actually, sucks the worst.
Hmm.
It's sad. Sorry, not sucks. I hate symbols.
My bioman asked what a vector is because everything meant that.
Yeah.
Yeah.
Right.
Yeah.
So I go tell him the definition, like, oh, no, I don't want to do.
Is your physical property that has
Tell him got magnetic direction.
Yeah, lor.
Then the other one,
first correct?
Don't understand.
he said, sure, they go physics. Too bad, too late.
Yeah, too late.
Sure the physics.
If you take triple science, then you know everything.
Not really.
You probably can handle that, but you don't want.
Not really. Okay.
You teach me, you think I remember? No.
No. Okay, so guys, please remember these 4 factors. So just to give you an idea, an example. Let's look at this example. Let's say in this direction.
Of one.
Come guys, quickly complete this fraction. Huh?
Oh.
Come, complete the direction. Balance it. Include stick symbols. Hopefully no one has forgotten. Calcium is still class, yes. Include stick symbols.
All carbonate soluble except for
Are you sure that's the rule?
it. All carbonate are insoluble
Except for
SP. Is it?
Yeah. Good.
Still remember that.
You still don't?
Wait, come here.
I
I
can.
It's solid, right?
Yes, it's solid.
remember I see come here on the line of the bus.
Okay, good.
I can replace it for
All chloride are soluble except for
it's
is it something? Oh, you don't know. You'll be lazy someday. So meaning what? What's the state? Calcium chloride. State.
What?
You better know for sure. Okay, yeah, that's the reaction. Now, the next question, he'll ask you how to increase the speed of reaction. Yes, that is the best one. But sometimes they won't give you a choice. If an MCQ, they may not tell you temperature at all. They'll give you something else. So yeah, increase temperature. How? Anything else? How else to increase the speed of reaction? Of what? Remember, concentration only applies to aqueous reactant. So you have to specify which one, HCl. You have to write it down, HCl. Anything else to increase the speed of reaction?
oh yes, solid.
What to do?
Size.
Yes. Crush your calcium carbonate into small percent because it's solid. So next,
Not crush.
not necessarily can come in a block.
Oh, like.
Practical it is crush.
Sorry.
那这个水，那一个，
Oh,
跟 throw on the floor 一样。 Okay. Too easy, right? So you all can understand it. But unfortunately, that's not the end yet. This is a short chapter, by the way. Not very short. Just one last portion. The last part, the fun part. Fun part. Fun. Okay, come. Catalyst. What are catalysts? Okay.
Something that catalyzes the reaction. Is reaction.
What makes reaction?
Yes. Substances. And increase the speed of reaction. But the but is important. But they are not a reactant.
What they go?
They only speed of the reaction without reacting.
So you fluid nothing. Okay.
Something will happen, but they will speed of the reaction without being used up. You touch on enzymes very soon.
Huh?
Yeah. It's included in this part, enzymes.
Oh,
You should study bio.
no.
Not use up. Yeah. Okay. The but is important. They are not reactants. Okay, there are all sorts of catalysts. However, you need to know they are specific. Yes, iron. Specific reactions. So for each for a different reaction, you have a different catalyst. Akam, what's the one you mentioned? For what reaction? Oh yes, excellent. You haven't learned that?
Okay.
Oh,
I don't remember such thing.
the catalyst is iron, and you also want the catalyst to be effective. So by right, you should use iron powder. Surface area matters as well. Okay, there are other examples like corn sulfuric acid. Okay, so your catalyst may not be a solid, it can be a liquid. Yes, those are quite rare, but it can be aqueous, it can be liquid too. Yeah. For this kind of reactions.
One.
Esterification. Yeah, so
Oh.
the other one you need to know is nickel. Nickel. Nickel.
Oh.
This kind of reaction, hydrogenation. Don't worry, coming soon.
What? Because like
No. Hydrogen is a reactant, but it produces something else, obviously. Something else. Okay, hey, you should know. No, nothing so fanciful. What's the difference between oil and fat? Yeah.
You learn that what?
No. Okay, then forget it. Yeah, but why differentiate oils and fats? Both can be useful.
It can hold for glucose.
Oils can also form glucose. Oils also can do different. Okay, but let's go on. You explain how. How to this speed up reaction? Okay. That's why you need to write down. Provide alternative you hope and reaction pathway. Later you see with take note, the explanation does not involve collision theory, so don't mix them up. Lower, and then you see your good old friend again.
Distance.
Activation energy. Why? Come. So when it comes to this, they ask you to draw a graph.
Oh.
Yeah, we're not done yet. Come. Let's see. Yes.
I need graphs.
I thought graphs are interesting.
No, I always think that. Especially the one.
Oh,
It's the one that requires my email. That I hate.
刚明天 what is H?
No. Wait, it's change entropy.
Yes, right now entropy. Yes, another old friend. Huh?
It's the energy.
You better go and look through the video.
Oh, now I've got it.
Yeah. But your teacher is going to be fussy. He wants you to write entropy.
Entropy.
But if let's say the question didn't specify, just put H there. Can maintain exo or endo. She said exo. Yeah.
Oh, it's what?
So
Oh, yeah.
yeah. Come in your own diagram, label the activation energy. Where is it? Are you sure? Activation energy. Where's the activation energy? Yeah, it's up. Huh? 进阶.
Oh.
Yes, which arrow? Label the delta H. So arrow is up or down? Okay, from here, go down. But of course, you're not done yet. Now, this one is no catalyst or uncatalyzed. But your question is going to ask you to draw a curve that has catalyst. Yes, then she knows already. Oh, never mind. Later I'll tell you. Cosine. Found it reading. Straight line. It's going to look like that. Almost except for one major difference. So your new graph is going to look like this. Just a small thing, one of the small things. So notice what happened to the activation energy. Forward. Yes, forward. But they'll ask you to draw the graph, so you better know how to draw.
Like very.
No, that's all they need. That's all they need. So make sure your graph shows these few things. Right. No catalyst, higher activation energy. With catalyst, lower activation energy. But for both cases, come in think what happened to the delta H? Yes, delta H is still the same. And genetic note. Okay, right, not too bad, right? Simple chapter. Yeah, it's almost the end already. Oh, can you add in? My explanation is not complete. So, actin particles. Because now you don't need that much to overcome the activation energy. So more of them will have the enough sufficient energy to react. That's simple as that. Okay, so last one. Last part. Okay, no, last part. Yeah, I missed out something. Okay, anyway, jump to the last part first. Last part already, guys. Come. Last part. That's right, enzymes. Actually, it's very easy. They are simply biological catalysts. That means they are biological molecules that speed up biochemical reactions. Yeah, like digestion. Oh, why? You can explain to me more. Huh? No need. Okay, as for the why, no need to use your lock and key theory. Just use this answer here. Same explanation applies. Huh? What lock? Lock and key. Yes. Yeah, now I take a photo send to him. But for enzymes, there's one question that I'd like to ask, and I shall tell you. It also gives you the same graph. It possible, but more than that. So they give you the same thing. Yes, make sure you know this endothermic reaction. Okay, I'm not going to label everything up. And they will draw a few different curves for you, maybe 3. Usually they'll go for 3.
Which one is the one?
Which one? Yeah. Okay. So then maybe one more. This one is too exaggerate. So they'll ask you which reaction uses, which enzyme is the best? Huh? Yeah, which one is the most effective enzyme? Green, blue, or red? Which one is the most effective enzyme? Which one uses the most effective one? Yeah. So yeah, of course. Come, Jingjie, make sure you can answer this. That's all. This one is the most effective enzyme. Of course, in case they ask why, because yes, lowers activation energy, and you better know where the activation energy is in the diagram. Simple, right? Jingjie, don't worry. No lock and key theory. Lock and lock. Okay, Jingjie, need to copy. No need. Really, too easy. Easy. Did I miss out anything else? I thought I did. Yeah, I know. I thought I missed out something. What is it? It's... Oh, yes. Sometimes they'll ask you to calculate the rate. They want a number. They want a number. But it doesn't come up all the time. But you have to be careful what the question asks. So let's say I take this one. No, it may not be so straightforward. It's not that difficult either, but you got to be careful because you make one careless mistake. You can make one careless mistake. Yeah, that's the thing. If you don't read the question carefully.
You cannot use gradient.
No. You have to use gradient. But there are 2 kinds of speed of reaction. You better look at the question. One is, okay, let's see. Okay, one possible question. Calculate, from the graph, calculate average speed of reaction. The word average is important. Yes, but if you think you won't make a mistake, then no need to write down. But I told you already, average speed of reaction. So
What is this?
Goes to total volume over total time. But once it's total time, the time at which reaction stops. And by the way, it has units too. So you better look at the graph. What are the units? Yes, but you have to write down the units for your answer. So if it's dm cubed, time is in seconds, make sure you write dm cubed per second. I'm trying to remember, don't lose that mark for the units. What if the other possible question is calculate speed of fraction? And yes, t equals to, let's say, 10 seconds.
Start
Subject A, no. That is when you play your tangent.
then draw.
Yeah, draw a tangent. You need to do your tangent. Tangent.
They won't give you equation.
No equation. You want equation? So this equals to the tangent. I think I don't have to explain how to use tangent, right?
Just do it lah.
So
Draw.
draw. Anything? Draw the tangent. After that, what are you supposed to do with it? 2 points on the tangent. Okay, then yes, use your gradient formula. Rise over run or whatever you want to call it. Yeah. Shit. So this is delta y over delta x.
Wow.
Yeah. So this doesn't come all the time. Once in a while. Can maintain. Don't miss out the word average. Okay, yeah, easy. That's all. Speed of fraction. Let me print out something for you. Speed of. Where Penny? I'll go.
X. Divide that X. Yeah, you can show that usually we are in the middle. And for what you are in X class, the one goes to the X to the one. But in terms of this one, it's X minus 1, right? So it's X minus 1 being square, right?
Why 1 squared?
This and this how
Yeah.
very well.
Wait.
One.
I mean,
A minus B putting square because A square minus 2AB plus B square, right? A minus B putting square.
yeah, what?
That's how we get this. We need to make sure that this thing, right, reduces to form your BC. Right? So your BC is X minus 1. If you take that as reference, you should be able to find that. Even if you cannot find it out, we need to know that in your answer one here, there's no X squared. So you need to reduce it or factorize it so you have that X squared. And string. Then how do you get your BC?
Just read.
So this day, whole things like that, right? You also able to dismiss the right. This one you prove. We can show that not enough. Okay. Therefore.
T.
T?
Only T.
No, not T, 6.
Oh.
Banana for me. Yeah.
Later.
Yeah, eat later. 1, 2.
I think we chose diamond. Okay. Old book. Old book.
Yeah, oh, but it's quite useful.
Chapter 讲
Yeah.
quite useful. You can still buy it.
I think so. They have updated. I think there's an updated edition. Okay, come. Just some warm-up questions for both of you.
Wow, I really need to watch.
Yeah, you should.
Your Chinese last time is done.
Chinese.
Yeah, one was you just don't.
But Chinese, you have to do it regularly and consistently.
So what do you do? Like you read, then what?
No, there's no through your textbook law, all the highlights, everything.
Then who's doing it?
Huh?
Because I don't want to tell you. Follow the text. I know the text. The power of words you see.
That's true. But at least you have to know the textbook words, right?
I don't. Words are so weird. Like I Google to me, then like don't have the equal by Google search.
So serious.
I understand.
哎，你在考虑？
Yeah, why?
Sorry, right?
You better remember, yes. I thought you are familiar with the carbonate rule. Jingqie, you have to remember all the solidity rules, right? It's important.
Oh,
It's important. Oh, it's going to screw up a lot of questions. You can,
Huh, wait, question 3 is
uh-huh.
can be C or D, right?
Question.
Just follow the picture. But you said at room temperature.
For the how come my version is different from yours?
Oh, no.
It's the same. Number 3. Think carefully here. There's only one answer. What is the difference between the two graphs? X and Y. Oh, Y and Z. But whenever, okay, I didn't emphasize just now. Whenever you see graphs, check for two things. One is gradient. Second is the end, the level. Is one level higher than the other? Because the higher level will mean what? For question 3, the higher level means more limiting vector, no? So think along that line also. Which is the limiting vector? Identify the limiting vector for number 3. Yeah, yeah. Number 3. That's the answer. Yeah. What's your answer, Jinji?
I don't know.
I don't know. Okay, come. I'll show you on the screen now for one. Yeah, magnesium carbonate. Make sure you realize that is the limiting reactant. So I hope you notice this is lower. The endpoint is lower. That means you have less limiting reactant. So which answer tells you that there's less limiting reactant? Right, we already know that limiting reactant is magnesium carbonate. So which answer tells you there's less limiting reactant? C is larger crystals, no? But it doesn't tell you the limiting reactant is less. It means there is only larger particle size. Yes. Answer is B. Okay, C only tells you different particle size, but that only affects the speed, not the final amount of product.
Wait, question 5. Where is zero?
Where is 0?
0 second.
0 seconds, question 5. Isn't it there? You mean you can't say that?
So why is the option of the faster?
Which one of the following times is the reaction fastest? Okay, then what's the best answer?
Yeah.
I mean, it slows down over time, right? Make sure you realize that. So the best answer is A.
No question.
No?
Is there? Which one is no?
One.
Got more, man?
Yeah, I'm just to
But you can have more question though. Just calculate the limiting reactants. But seriously, Jinjie, you may be asked to calculate number of moles for the limiting reactant.
Never saw.
Huh? Haven't ah?
Oh, subject, right? Yeah. I think even by the time I say.
Oh, no, don't say that. Oh, all done already? Done, ah? Anything all done? Yes. Okay. It's okay. It's not a test, it's not an exam. Yeah, marble chips.
Marble chip for boy.
Yeah, but you can do other things with it. What is inside marble?
I don't know.
Chemicals.
I don't know.
Come, we can write down. In case it comes out, marble contains calcium carbonate. You may need to know that. Not all the time.
Yes, okay.
Marble.
Because if you don't know that there's a ration, then they say already.
You're right.
Hmm?
You're right.
Yeah.
Should we go holiday the Friday?
Oh, sorry about Friday.
Should we go pick up the Friday? Next Friday?
But
This Friday.
why? No. No. Friday, I want to have my public holiday.
Sorry, the Friday.
Okay.
That is a good Thursday.
Good Thursday. No such thing. Only Friday is good.
Friday feels depends.
Okay, come, Ling number one. You better get it. All right, if not, I don't know what to say.
Oh,
Jinjie, mark your answers, huh? Okay, number two. Which diagram shows the results obtained? More concentrated, dilute. Yeah. Jinjie, number two. No. Dot. D. No. B. B for boy. No.
no, 不知道。
What?
Experiment 2 uses more concentrated HCl. More concentrated means faster means steeper gradient, no?
Oh, I forgot I said the wrong thing.
There goes your mark. Yeah.
They're supposed to have the same in the end. Yes. No?
Yeah.
Really?
Yeah.
Why?
Steeper gradient, right?
I thought you said
Yeah, but they didn't mention anything about the amount. You can't do any calculation either. So you only can work on more concentrated means faster. Faster means steeper gradient.
but is it steeper already?
Yeah, that's why.
I still don't understand why steeper.
Steeper means harder to climb up.
Can you imagine?
Compare this slope versus this slope. This slope is harder to climb up, so it's steeper.
But shouldn't the bottom one is harder to climb up? Experiment 2.
Yeah, that's why. So this experiment 2.
Oh, yeah, so it's correct.
So there goes your marks.
Thanks,
Okay, 2 marks gone. Time number 4, Jinjie. Here, more conditions. Good. Number 5, we had already done it. Number 6, Ling. B for boy. Okay, Jinjie, check your answer. 7, Jinjie. Decreases.
8.
Okay, too easy. Okay. Any final questions for today? Yeah. Careless.
No, it's fine.
Okay, if not, then that's all for today. Can you stand at the counter there?
Yeah, I want to see. More Ian mine.
Why?
Yeah.
Or is it very easy for you? Like, is it how you do?
Oh, it's okay. Average.
Oh,
What's your question again? I can't remember.
I sent you. I forgot. I didn't bring. I came for school job. I didn't.
Okay, that's all for this video. Layden, in case you're watching this.